Section 6.4, Adding and Subtracting Rational Expressions. We'll start off with a look at a couple blue boxes. Blue boxes with which we should already be familiar, just knowing how to add and subtract fractions. Here on page 416, at the beginning of the section, blue box just below the center of the page, adding rational expressions with the same denominator. It says P over Q plus R over Q equals P plus R over Q. So what does that tell me? To add fractions, or now to add these rational expressions, you add the tops and write that result over the common denominator. Same thing goes for subtraction, page 419 at the bottom. Subtracting rational expressions, same denominator. P over Q minus R over Q equals P minus R all over Q. So to subtract fractions, or indeed rational expressions, we subtract the tops and write that result over this common denominator. Now, we have a blue box on page 417 that we're going to investigate a little more closely next time. We're going to split this section into two parts. But let's run down through this blue box called Adding Rational Expressions, Different Denominators, because we want to keep these steps in mind. Today we're going to have primarily common denominators. But these steps are still the approach to adding rational expressions. Step 1, find the least common denominator. Step 2, write each rational expression with that denominator. We're going to worry about those two steps more next time. Step 3, add the numerators and write that result over this common denominator. Step 4, what? Write in lowest terms. So again, nothing new. These are the same rules that we use anytime we work with fractions. Today we're primarily going to focus on those rational expressions that already have a common denominator. And next time we'll look at when the denominators are different. Let's warm up with some fractions, just some plain numeric fractions. To add these two fractions that have a common denominator already, we add the tops. 2 plus 8 is 10, and write that result over this common denominator. In other words, 2 of them plus 8 of them totals 10 of them. 10 what? 10 fifteenths. And then, to get our final answer, we reduce this to lowest terms, dividing the top and bottom by 5. Or as we've shown recently, we can factor the top, factor the bottom, and cancel those 5s. That really looks more like what we're going to be doing as we work these problems in rational expressions. But either way, get this in lowest terms, and we've got our final answer. Let's start off nice and easy. Let's head over to the homework set and grab some problems. I'm going to start this time with number 12. Don't make these harder than they are. They'll get tough enough quickly enough. Just think about what are the rules for adding fractions. You add the tops and write that over this common denominator. In other words, I have 5 of these plus 12 more of these totals 17 of these. 17 what? 17 over P. There are no common factors to the top and bottom, and so that one's already in lowest terms. Add the tops, write that result over this common denominator. Number 14. Again, we already have our common denominator. The two denominators match. So we are ready to subtract these numerators. 6 of them minus 3 of them That's a difference of 3 of them. 3 over that common denominator. Reduce this to lowest terms. Again, please don't make the mistake of canceling those 3's. 3 may be a factor here in this numerator, but 3 is a term in this denominator. It is not a member of multiplication. It is not one of the factors of the denominator, and so this is already in lowest terms. Now, when it comes to subtracting rational expressions, there is one thing that I like to do because it keeps me out of trouble. I like to think of it in terms of addition. I can give this negative to that numerator. Remember, a negative can live one of 3 places in a fraction. It can be out front, it can be in the top, or it can be in the bottom. Well, let me give this negative to the top. In other words, let me distribute this negative to each term. Well, there's just one term there in the top. And now this is an addition problem. We get the same answer. 3 plus a negative 6 is still positive 3 for my numerator. But this idea will go a long way to keep us from losing dumb points, right? From silly sign mistakes. Number 16. The instructions read add, or the instructions read simplify. And I check and I see I already have a common denominator. So I'm ready to add these fractions, these rational expressions. I do that by adding the tops, a plus b. Well, those are unlike terms, so it's just a plus b. And write that result over this common denominator, which is a plus b. Reduce to lowest terms. The a plus b is a factor, the only factor, common to the top and bottom. Or I could say what? Something over itself is 1. Otherwise I'll say, well, everything cancels, leaving behind what? That residual factor of 1, that multiplicative nothing. Add the tops, write that result over this common denominator, and reduce to lowest terms. Number 18. Now remember what I said about subtraction. My instructions here read subtract, or perhaps they would say simplify, but more than likely they read subtract. Instead of subtracting, I think we're better off to think of this in terms of addition. I want to give this negative to that second numerator. By distributing that negative, changing the sign on each and every term in that second numerator. I mean, that's how we subtract polynomials. And these are a couple of polynomials. They're the numerators of rational expressions. A rational expression is a polynomial over a polynomial. How do you subtract polynomials? How do you subtract these numerators? To subtract polynomials, you distribute the negative and what? Combine like terms. So that's all we're doing here. But by distributing that negative to that numerator, it's going to keep me out of trouble. Now, add the numerators. That is, combine like terms. 4x plus a negative 3x. 4x minus 3x is x. And what else do we have? We have a minus 2. Write that result over this common denominator and check for lowest terms. The only factor in the top is x minus 2. The only factor in the bottom is x plus 2. They don't match, nor are they opposites. And so this is in lowest terms. Those two factors really have nothing to do with each other. And so that is in lowest terms. Number 20. I want to subtract these two fractions that already have a common denominator. So I will subtract their numerators. To subtract polynomials, we distribute the negative and combine like terms. So let's distribute this negative. Keeps me out of trouble. And combine like terms. We have x minus x. We have no x's. The x's subtract out. Minus y is minus 2y. And this is all over this common denominator. Reduced to lowest terms. There is a common factor this time of 2, top and bottom. If we cancel those 2's, that leaves me in the top a negative y and what? Over 1, but we don't write over 1. Number 22. Our instructions here would say add. I already have a common denominator, so I am ready to add up these numerators. T squared and plus a negative 3t. Those are unlike terms, so the best I can do is t squared and minus 3t. Now check for lowest terms. How do I check for lowest terms? I check to see if there are any factors common to the top and bottom. If I'm checking for factors, I need to see everything in factored form. Let's get the top and bottom factored completely. And this numerator has a greatest common factor of t that I can factor out, which will leave t minus 3. The denominator is prime. Well, I'm glad we checked, because these t minus 3's will cancel to leave simply t, what, over 1, but we don't write over 1. And why is that again? Because t over 1 is not simplified. T divided by 1, anything divided by 1 is itself. And so t over 1 would just be t. Number 24. Getting into a little bit bigger problem now, so I should probably start writing a little bit smaller. Add these fractions, add these rational expressions. They already have a common denominator, so I'm ready to add the numerators. All of the terms in these numerators are unlike terms. So when I add these numerators together, I'm simply going to get r squared minus 8r and plus that 15, all over this common denominator. Now, are we done? Well, I'm not sure. I haven't checked for lowest terms. Checking for lowest terms means I need everything factored. That numerator might be factorable. Let's see if it is. If that numerator factors, it'll factor as a pair of binomials, each starting with r. Signs are the same, in fact they're both minus. I need two numbers whose product is 15, whose sum is negative 8. How about minus 3 and minus 5? This denominator, of course, is prime. It's a good thing we checked, because there is a common factor of r minus 5, top and bottom. And so, simplified, we get simply r minus 3. It would be over 1, and we don't write over 1. Number 26. Subtract. Well, I already have a common denominator. I see it's a difference of squares. I'm not interested in factoring at this moment. Now, in the second part of this section, we are going to have to factor at this point in some of our problems. But in this problem, think about what we're doing. We've been charged with subtracting these two fractions. They already have a common denominator, so what do? You subtract the tops. How do you subtract polynomials? You distribute that negative and combine like terms. Give this negative to the second numerator. Give that negative to the second numerator, and now it's plus, and that's a positive y. So add the tops, and I'm going to write them in descending powers. I'm going to put that y first. And what? Minus that 4. And this is over this common denominator. Now I'm interested in factoring, because now I'm interested in checking for lowest terms. Is this fraction in lowest terms? Well, I don't know. This denominator can be factored. It's a difference of squares. So let's get it factored and see what happens. The numerator is prime, nothing I can do there. And this denominator will factor as the first plus the last times the first minus the last. And I do have a common factor top and bottom. This y minus 4 will cancel. To leave, in this numerator, what's left behind? Nothing, the multiplicative nothing, which is a 1, and over just that y plus 4, who no longer needs his parentheses because he's the only factor down there. Enjoy the problems now, because next time we're going to be looking at unlike denominators. And you can see that in the problems 29 through 52. We're not going to worry about that right now. But I do want to jump down and tackle one more type of situation. And it starts here in number 55. And if you look at the denominators in the problems at the bottom of this page, starting with number 55, you'll notice they're opposites, aren't they? Those denominators are opposites. We're going to work number 56. And in number 56, these denominators, m minus 2 and 2 minus m, are opposites. Now, let me put this problem on hold for just a minute. Let's work a couple numeric examples, okay? Consider, if I ask you to add 3 over 7 plus 2 over negative 7. Well, to add fractions, you have to have a common denominator. So what are we going to do about this? It's not already a common denominator, but they are opposites. How can I change one of these to match the other? Well, I could multiply the top and bottom by negative 1, couldn't I? And that would give me my next step, that would give me a negative 2 over a positive 7 to add to my 3/7. And that's going to total positive 1/7. Now, I want to kind of streamline this right here where we are changing this denominator to its opposite. You can certainly do it by multiplying top and bottom by negative 1. But what else do we know about negatives that live in fractions? Negatives that live in fractions can live in one of three places. They can hang out in the bottom, or they can hang out in the top, or they can hang out front. In other words, 2 over negative 7 is the same as negative 2 over 7 is the same as negative 2/7. Those are all equivalent. So one thing I could do is take the opposite of this denominator and give that negative either to the top or to the front. If I were to give this to the front, this would become a subtraction problem, right? And either way, we would still get our what? Our positive 1/7. The way I have it written now, it's 3/7 minus 2/7, a difference of 1/7. So I want to think of this as taking the opposite of the denominator and giving the negative to either the top or the front. Now, quite honestly, generally when it's an addition problem, I will give that negative to the top. If it's a subtraction problem, I generally give that negative to the front and change my subtraction to addition, which I like better anyway. Let's do another numeric example. If I ask you to add 4/11 plus 9 over negative 11, well, one way to do this is to take the opposite of this denominator and give that negative to the top. Take the opposite of this denominator and give that negative to the top. And if I do that, I now have a common denominator of positive 11. Add the tops, that's going to be negative 5/11. You can write that negative out front. There's no harm in leaving it there on the numerator. But now consider this. That's not the only way to work this problem. 11, positive 11, does not have to be the common denominator I use. I could say, well, these denominators are opposites. All I have to do is change one of them. Over here, I changed the second one. What if I chose instead to change the first one? Well, take the opposite of that denominator and give the resulting negative, let's say, to the top. Just taking the opposite of the top and bottom, right? And so what's this going to give me? As I add these numerators, I get a positive 5 over this common denominator, negative 11. And of course, you know that these two answers are the same, and either one of them could have been written as negative 5/11. Let's keep this idea in mind now as we work number 56. And I want to think about it like this. How did I do this numeric problem with my 11s in place? I said, okay, I'm going to pick the second denominator, take his opposite, and give the resulting negative to the top of that same fraction. Let me do exactly that. Let me take the opposite of this second denominator and give the resulting negative to the top of that same fraction. Now, I want you to think about this. You had a 5 over 2 minus m. If you wanted to take the opposite of the top and bottom, you could multiply the top and bottom by -1, right? And what would that do? In the top, 5 times -1 is -5. In the bottom, you would distribute this -1 to each of those two terms, which would give you what? If I put it in descending powers, -1 times -m is m. -1 times +2 is -2. That's what I got. I'm just taking the opposite of the top and bottom. And I like to think of it as take the opposite of the bottom and give that resulting negative to either the top or the front. If it's addition, I generally give it to the top. If it's subtraction, I'll give it to the front. And we'll have a chance to see some of that. Having done this, I can now, with a common denominator in place, I can add the numerators. 10 plus -5 is 5, and write that result over this common denominator. Now, that's not the only way to work this problem. As we saw with our 11s a minute ago, it doesn't have to be that second numerator I deal with. I could have dealt with the first numerator. So let me just make a note over here that our answer was 5 over m minus 2. And let's go back and do this one again. But this time, let me work on the first fraction instead. See, I can take the opposite of this first denominator. Now remember, we talked about opposites in 6.1. You turn a subtraction around, you have the opposite. And give that resulting negative to this numerator. Just like the second way we worked that problem with the 11 and -11. Add the tops. -10 plus 5 is -5 over this common denominator. Is that the same answer we got before? You should be able to see that yes, it is. Start from here. Take the opposite of the top and bottom. Doesn't that give you a positive 5 over m minus 2? Or start with that one. Take the opposite of the top and bottom. Doesn't that give you this answer? Either one is right, and it does not matter which way you do it. Let's work a few more of these. I did not mention it in the problem I just erased, but we did need to check it for lowest terms. I considered that one to be obviously in lowest terms. Number 58. On a lot of these problems in the back of the book, she will have written the two different forms of the answer depending on which denominator you decide to work on. I miscopied that problem. Let me get the problem copied correctly. Now we can get going. Here on number 58. This is a subtraction. My denominators are opposites. It's an easy task to get a common denominator here. I just need to take the opposite of one of these denominators. I'm going to choose to work on the second one. I'm going to take the opposite of this denominator and give the resulting negative to the front of the problem, which will change that subtraction to addition. Nice. Now we have a common denominator. Now we can add our numerators. Combining like terms, we have p and minus 3. This is over p minus 3, which simplifies to just 1. We would get the same thing if we had chosen, we'd get the same final answer, a little bit different middle step, if we had chosen instead to work on that first denominator and change it to a 3 minus p. And you can try that one. You can try that on your own. Number 62. I'm subtracting fractions. I need a common denominator. I notice that these two denominators are simply opposites. I need to change one of these denominators to match the other. I'm going to choose, as is quite often the case, to work on this second denominator. Take the opposite of this second denominator by turning this subtraction around and give the resulting negative either to the top or to the front of that fraction. Since that's a subtraction and I like addition anyway, I'm going to give it to the front. If I had given it to the top, I'd end up right back where I was. If I had given it to the top, then I would have come in and I would have said, well, let me make this addition by distributing this negative. It'd still be plus s, right? So I prefer, when I'm dealing with a subtraction problem, take the opposite of that second denominator and give the resulting negative to the front of the fraction. And that just goes ahead and changes me over to addition, which we like better anyway. Now that we have a common denominator, we can add the numerators. The numerators are unlike terms, so that will be simply t plus s all over this common denominator. Now, if someone chose to work this by adjusting the first denominator, I worked on the second denominator, but if someone adjusted the first denominator, they would have gotten, well, the opposite of the top and bottom of our answer. Opposite of the bottom, we know, turn the subtraction around. Opposite of this numerator, well, it's an addition, so the best I can do is distribute a negative 1. So if someone chose to work on the first denominator, this is the answer they would have come up with. And I think it's important that you be able to compare these two answers and know that they are indeed the same. Let me give you a quick one to do. Number 64. Let's get it copied up here, and then you can pause the video and then come back and we will compare answers. And I'm going to work this 2 different ways for you. Go ahead and give that one a try. All right. I personally, in working this problem, because it's a subtraction, I would probably affect the second denominator. I would turn him around, I would take his opposite and write 3 minus 7y and give the resulting negative to the front of that fraction. Now I have a common denominator. I'm ready to add the numerators. 8 plus 2 is 10, and that's over this common denominator. That's one way to do the problem. Let me back up and do it again. Maybe instead of working on that second denominator, your preference was to write your denominators in descending powers. And if that were the case, you would have affected the first denominator, leaving the second one alone. Again, our goal is to get a common denominator so that we can subtract. So if that's what you did, you would have turned this one around. Take the opposite of this denominator, you get 7y minus 3. and give the resulting negative to the top. Since this is a subtraction and I don't want to make some silly mistake, I do like to change this to addition by distributing that negative. Give that negative to that second numerator. Add the tops. Negative 8 plus negative 2 is negative 10. And that's over this common denominator. A moment ago we got a positive 10 over 3 minus 7y. You should be able to recognize that that is equivalent. Just multiply the top and bottom by negative 1. Take the opposite of the top and bottom. That is equivalent to negative 10 over 7y minus the 3. How'd you do? Finally, let's have a look at number 66. I need to subtract these fractions. I need to subtract these rational expressions. To subtract rational expressions or fractions, I need a common denominator, which I don't have yet. But I do notice that my two denominators are simply opposites. Let's change one of them to match the other. I'm going to affect the second denominator. You could do it either way, as I've shown you a few times already. But I'm going to work on the second denominator. I'm going to take the opposite of this second denominator and give the resulting negative, in this case, to the front of the problem. If that had already been addition, I would have given the resulting negative to the top of the fraction. We now have a common denominator. We're ready to add the tops. Those are unlike terms, so we simply get 24y plus a negative 20, we simply write minus 20 over this common denominator. Now, are we done? You are always checking for lowest terms. Always checking for lowest terms. Are there any factors common to the top and bottom of this problem? Well, this numerator is factorable, isn't it? There is a greatest common factor of 4 that can be factored out. Factor out a 4, which leaves a 6y and a minus 5. This denominator is prime, and it's a good thing I checked, because there is a common factor top and bottom, which when I cancel leaves me my final answer simply 4. So for now, I'm going to assign the homework in only those groups that we've worked in. So that would be starting with number 11 through number 27, and then where we dealt with these opposites starting with number 55 through 65. It's on your homework assignment sheet, don't worry about it, and you'll be reminded of which problems to do when you look at the assignment on our little web page.